Hello, this is Bono. Today, for anyone who is about to start out in electronics, I want to go right through the basics of how to use a breadboard. Once you know your way around a breadboard, you can put a circuit together quickly and without any fuss at all, and that alone makes electronics a great deal more fun. Here is what today's video covers. By the end of it, you will know enough to go and wire up a breadboard yourself straight away, so please do stay with me right to the end. This channel posts videos that teach electronics from the ground up, the knowledge a beginner needs at minimum, explanations of the tools, and so on, in an order that builds. If you are just about to start out in electronics, please do subscribe so that you don't miss any of the ones still to come. Right, let's get into it. First, what exactly is a breadboard? A breadboard is a board used for putting circuits together. The board is covered in holes like this, and you can push components and wires into whichever ones you like. When you build a circuit in electronics, it is generally one of two things: this flat board called perfboard or this breadboard. The advantage of a breadboard is, above all, that there is no soldering involved, so you can put a circuit together quickly and easily and change it as you go. The downside, on the other hand, is that it is not very reliable. Inside, a breadboard only grips the pins, so you get intermittent contacts and parts work loose. There is also a limit on the current each pin can carry, so it is not suited to high current work. So hooking up a lot of motors is best avoided. To make that a bit clearer, here is a comparison with perfboard. The pin pitch, the distance between holes, is the same on both. As you can see, the very same parts fit into either one. How much current you can pass depends on the wire and the solder, so perfboard itself puts no limit on it. Push it too far, though, and the board itself will scorch, so do keep an eye on it. On price, perfboard tends to be cheaper, being the simpler thing. Look on Amazon, for instance, and you can see that perfboard comes out cheaper. Next, let's go through how you actually use a breadboard in practice. The holes split into two kinds: the power and ground holes and the signal holes. Two kinds of hole: power, GND, and signal. The power and ground holes are these red and blue lines running down either side of the board, and each of those lines is joined together inside. Red is positive, so that is the supply side, and blue is negative, so that one goes to ground. That is the usual convention, and worth sticking to. Just like in a spreadsheet, the columns are given letters and the rows are given numbers, so every hole has its own address. The AE columns and the FJ columns are separated inside the board, so they count as two different groups, and within one group, every hole in the same row is joined together underneath. Some boards use red and black instead, or have no plus and minus marks at all, but they work in exactly the same way. To get a better feel for it, let's take a look inside a breadboard. I had a cheap spare board lying about, so let's take that one apart and have a look inside. First, peel the double-sided tape off the back, and you see rows of metal bars. Each of these metal bars is a single connected piece of metal, all the way along. Let's take one of the bars out as well and see what is underneath. And out comes a contact, like this. The contact is shaped so that it grips the leg of the component you push in. Push a component in, and it looks like this. The contact holds the leg firmly from both sides, which is what keeps it in place. Now let's take out the metal bar that serves power and ground as well, and compare the two. Right, and out it comes. It is simply longer. The shape is exactly the same. So you can see that a breadboard is a simple thing. Underneath, it just grips the legs of the components you push in. Now that is clear. Let's go and build a circuit. We will make the classic blinking LED circuit, resistor and LED into the signal pins. The LED has a polarity, so mind the direction. It is a little hard to see, but the longer leg is the anode and the shorter one the cathode, and current only flows from anode to cathode. One side of the resistor and the anode of the LED are joined together in the circuit, so put them in the same row. This row here, in our case. Next, connect the battery. You could go into the signal pins directly, but we want to cover the power rails here, so it goes into this line first. Then from the plus line to the resistor leg that isn't connected to the LED, and from the minus line to the cathode of the LED, and the circuit is done, the LED lights up as it should. That covers the basics of using a breadboard. One quick tip before we finish. While we are on the subject, most breadboards have these ridges and grooves, so you can clip them together like Lego bricks and make the working area as big as you need. Worth remembering if you ever run out of room on a single board. That was a look at how to use a breadboard, aimed at anyone about to start out in electronics. None of it is difficult, and once you have built something on one, you will get the hang of it quickly. I plan to cover tips for building circuits and how to choose a breadboard in other videos, so do have a look at those as well. If you have thoughts on this video, do leave a comment. A thumbs up is always very welcome too. Until next time, enjoy your electronics, and I will see you in the next one.